Okay, welcome back. This is going to be, I think start a new, we're going to start a new project. We're going to look into GitHub here and start a new project. I think for API sauce, I think that was pretty good. I think we covered enough there. So I'm just going to plug in a search. So we're going to search JavaScript public, nothing that's been archived, stars, something that's been pushed recently, and we're just going to sort descending. Okay? All right. This is it's like a Spanish. That looks, I don't even want to guess what this is. Japanese. It's not Korean. Doesn't look like Korean. AI agents. It might be good to do something with AI just because it's so popular. And that's really what we're looking for. We're looking for something that's got activity, something that's relatively popular. It's got some contributors, a good amount of contributors on it. And then obviously some room for improvement when it comes to functional programming and JavaScript, right? Node.js implementation of a web audio API. It's got some issues. Let's first look and see. Okay, 13 contributors, that's good. JavaScript, 96%, great. Let's take a look at some of the issues. Server. Okay. Okay. So I'm not exactly sure if modify incoming array buffer allocation failed while trying to decode large files. Shouldn't you be streaming that, not buffering? Why are we okay? Should be trying to stream that. I'd be trying to stream that, not buffer it, but okay. I mean, this looks relatively interesting. There's a, like I said, good amount of contributors on it. It implements the web audio API spec on Node.js. Oh, okay, cool. All right, so okay, so this is a contender. And it's audio, so it would be good to, you know, listen to some music as you're working on this, fixing some things. Okay, so we know we've got some issues. Let's look at the tests. This is 4 years ago, though. Not terribly recent. People are still... Oh, we're using underscore. Oh, that should be Ramda. Okay. And we're just using the built-in assert. Okay, so this is kind of like API sauce, where it's recent, but there's still some parts of it that are like really old. So we're just gonna keep looking. It's a good one. It's just there's not a lot of recent activity on it. All in web browser. I'm not really into frameworks. There's just a lot of work already being done on frameworks. Django. Let's see. Fastify. But it's a ghost editor. Don't really want to have a whole video where I'm just scrolling and looking. So let me pause. Let me just pause here, and I'll take a quick peek, and then I'll come back when I think I found something. Okay, so I think I found something in the AI space. So this project is called 9router. It has recent activity, so 17 hours, 2 months, last week, last month, right? A lot of this is recent activity. This is 99% JavaScript. It has 37 contributors, and it's about connecting AI code tools. So this is something about never stop coding, auto route to free and cheap AI models with smart fallback, connect all AI code tools. Okay? Stop wasting money and hitting limits. Maximize subscriptions, auto fallback, multi-account, round robin between accounts per provider, which is kind of interesting. Universal works with Claude, Codex, Gemini, Cursor, etc. So you have a CLI tool that connects to the 9router via a local host, a router, and it takes care of quota tracking and refreshing tokens. And then that goes to tier 1, tier 2, and tier 3. Never stop coding, minimal cost. So I guess it's literally just behind the scenes, making sure that you're maximizing your subscriptions, right? Which is this track quota. Use every bit before you reset. Yeah, interesting. So connect a free provider, no sign up needed. So you can actually use free providers with this library, this tool. So this looks interesting. There's a video tutorial I might take a look at that later. Not on this video, but just look at it later. And then, yeah, supported AI tools and providers. Okay, so I think this looks interesting to me. It's like I said, it's recent. It's kind of ticking all the boxes at this point. Take a look at some of the issues. How to switch the model automatically. What's this? 9 hours ago. To use the proper one for every request. Okay. That's anti-gravity. Implement first-party provider. Authentication. So, I mean, there's quite a few issues. There's 96 issues. Yeah. Let's take a look at some code and see what we've got here. So we'll come into some of the tests and just kind of see embedding tests. Dictionary tests. Oh, this is just kind of how everything's laid out. It's kind of cool. It's helpful to have a README for the test. Okay, so last month we have this embedding core test. Okay, so so VI test looks like the testing framework. Let's see, VI test, JavaScript, TypeScript maybe? Testing framework. Maybe this is it. Next generation testing framework. VI test. I definitely haven't used this before, so this will be interesting. Okay, just compatible. Smart instant watch mode. Interesting. Oh, it reruns your test for you? That's interesting. Watches and reruns. Cool. Okay. Right, so got some tests here, some mocks. Oh, why are we writing functions like this? Huh. I wonder if this is... Okay. A minimal success response from a provider. Okay. We are... Yeah, so you see how they're kind of just returning this response. Like, that's already a pattern that we can see that we can abstract into a more helpful, more generic, more descriptive function. So that's a... Yeah. Alright, so you're not typing this out. Yeah, because really the only thing that's changing is what you're passing into the response, right? Or rather, what you're passing into JSON, what you're passing into the stringify here. That's the only thing that's changing between these two functions here, right? So this should just be its own function that takes this as an argument or a parameter. It's just going to take an object, right? It's just going to take whatever you give it, and it's just going to stringify it, and then everything else it will just do, which is pretty simple to me. I don't see why we can't just make that one function that you just call on both of these. Standard valid embeddings. Response on AI format. Okay. I mean, I guess it's a style choice to write a function using the very, how do I say this? There's many ways of defining a function in JavaScript. This is more or less a well-known, more legacy. I'm hesitant to use the word legacy, but I would say in modern JavaScript, this defining functions this way, it would be considered sort of like legacy uh, definitions because I mean it works, it's fine. It's just that most JavaScript libraries out there, modern JavaScript, don't really define functions this way anymore. Okay, but there's quite a few mocks. Okay, so this is interesting to me. Let's look at the cloud test. Let's take a quick peek at that. Some more mocks, imports. Request object, make a request. Cores. Okay, pretty straightforward stuff I'm seeing. Let's take a look at some source. I want to look at the lib maybe. And then there's some top level files here. So there's some database stuff here. Let's look at the usageDb. Okay, so something called lowDB. I'm not really sure what that is either. I haven't used that. Whoops. Let's take a look at lowDB. Oh, a JSON database? Okay. Plain JavaScript to change data. Post. It's like, okay. LowDB has 38 contributors. This looks like it might be a yeah. Oof. I mean, it's a database, so yeah, and it's been around for a while. Interesting. Okay, so they're using that. Determine if it's a cloud is basically a cache type object. Put the app name for the root. It is cloud. Skip file. Okay, we're hard coding. Okay. Path. Try catch. Get user data directory. Okay. If try if turn. Okay, so we could clean this up. There's two try catches I'm seeing thus far. Try catch is actually you can make that a function, so that it's just a function you call, much like the if else that we looked at or that I talked about. Yeah, I guess we did look at it. So Ramda has Lambda has a try-catch function. And the nice thing about this is that you can pass the function that you want to try, and you can pass the function that would actually throw, or the catch. Basically, there's a try, and then there's the catch. And, it's basically going to run, this function is going to run either function that's passed in. So if there's no error, then it's going to return the result of just trying. If there's an error, or if there's there's an error, it's going to run the catch function and return the result of the catch function. So, yes, it's in Lambda, and that's great. It's also in, I think Crocs also has a try-catch, but the point that I'm making is that even if we didn't want to, because it looks like they're explicitly using like the built-in Node.js libraries, so they're not really pulling out like a third-party library and pulling it into their library, like we looked at in the last project that was using Lodash. They're just using built-in stuff. I mean, yeah, they're pulling in a database, and that's fine. But if you don't want to, I understand that libraries don't want to pull in a third-party library into theirs, and they just want to keep it as light as possible. I get that. But I think even in this scenario, you could write your own try-catch, right? And that would clean up a lot of this noise. As functional programmers, that's just what I'm seeing is like, there's try-catches all over the place here, in several places. Okay, so there's ifs, a lot of ifs. Yeah, so you see where we need comments, where they need comments here to ensure the data directory exists. That's basically what this is doing. One of the things that another thing I want to mention is that when we write functional programs, we want to try to make the program as readable as possible for the reader, right? Even your future self, who may be coming back and looking at this code a week from now, a month from now, a year from now, you want to make it as readable as possible. And I understand comments are needed, but ask yourself, why am I adding a comment here? And can I write the code in such a way to where it doesn't need comments, right? If this is really about ensuring data directory exists, why not just create functions, maybe a grammar that allows you to express that here, right? That you're just checking to see if a data directory exists. And then all of this can just be, it can still be used, but it can just be boiled away into a function, or kind of, yeah, it can just sort of be reduced to a function, and then that function can have a meaningful name about checking to see if a data directory exists. And then you just use that here, right? And therefore you wouldn't really need to comment. At all, because it's pretty self-explanatory. We're just checking to see if the data directory exists. Right. Okay, so we have a singleton here, sending it to null, and then database instance is being used in some different places. Okay. A global, so we're using a global to share pending state across routes. Track the last error for UI edge coloring. That's interesting. track a pending request. Track by account. Track error provider. Auto clears after 10 seconds. Okay. 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 So pending request. So yeah, it's either going to be something like this or something like this. Do you see the pattern here on these two for pending requests? By model, by account. Okay. So this could be a function call because this is all pretty similar to me. Track by account. Yeah. Okay. So there's some. Okay, so we have a connection map where build active requests from pending state. Entries. Oh, okay. So, yeah. So, we can clean this up too. This doesn't have to be a nested for loop like this. We could just reduce on that, and we can just reduce and produce a new active request, essentially. Okay, and then get recent requests from history. Get recent requests from history. So reread to get the latest. So that means that history there's like a list basically of history, and we're trying to get the most recent requests. We're trying to figure out what the most recent requests are, right? And that's okay. So yeah, sorting. So recent requests, history, sort, and then map, and then filter. So map, and then from that map, filter, and then slice. The first 20 looks like. Okay, so this could be done a lot. I mean, this is okay. This is actually okay. This is the reason why this is okay is because it's using they're making an attempt to do some functional programming here by using higher order functions, right? That's why this is okay. We've got a higher order function to sort, then another higher order function to map, then another higher order function to filter, and then we're simply just taking what we think are the most recent requests in history. Okay, so we can actually clean this up and make this a little bit more efficient by using we could still reuse this sort. There's nothing wrong with this sort, right? And then we could clean all of this up by just saying, look, we're gonna run through all of these sorted requests one time by just reducing over their request. Because when you take the last 20, those last 20 are built based from this filter, right? So if I'm walking this backwards, I'm only going to take 20 or 19 or whatever this slice returns. But I'm only going to take a subset of the sorted request, the sorted request. And when as I'm reducing over these sorted requests, I can do the map step, which is this entire step right here, which is basically just a function. And then I can determine from that map, where is it? The prompt tokens and the completion tokens, right? So I can determine from that one map, so taking one recent request, mapping over it, and then looking at the result of that map, and then applying this function to tell me if it needs to be in my accumulator, my running accumulator, or not in my reduce, right? So I could go over this one time, have my nice subset here, right? I could even have my accumulator, I could have my reduce just give me, yeah, so return just this count here, right? So yeah, this could be cleaned up. Get active requests. This is, so yeah, it's doing a few things. It's building active requests from pending state. We can clean that up, and then get recent requests from history. Yeah, so get active requests can be cleaned up significantly. Let's see. Get usage database. Return in-memory database for workers. Let's try catch again. And then we're trying to read the database with error. Okay. Alright, so it looks like there's some opportunities here, actually. Right? Save request usage, add timestamp, ensure history array exists. Yeah, I mean, if. You see these cascading ifs? It's fine. It works. It's okay. We're just applying filters if there's filters to apply, right? So that's the pattern. If there's filters to apply, we're applying them, right? That's all. And then we're getting the history. Okay. So we could clean this up. All you're doing is you're getting history, right? You don't even need to, if you're returning the history here, you don't need to you could just compute it. as you, so you could just run through this as, you could run through this as a composition or a pipe, and where you're checking along the way, and then uh, you're just returning either. Because you're saying, okay, so get the database and then get the history from the database. Or if there's no history, then just give me an empty array, right? So, and then from that history, you're mutating, or you're not mutating, but you're assigning whatever you're whatever you're filtering on this side. So depending on what you got from get usage database, you're just going to try to filter that down for a provider, for a model, for a specific start date, an end date, and then depending on what you have, you're just returning what you have, right? So this could be written more functionally, and we'll look at that. Format long date. Okay, I like that we're creating a function here called pad to be used here so that you're not constantly rewriting this a million times. So that's good. I like that. That's recognizing that there's that you would be repeating yourself, right? So I do like that. And this is fine to me. Format long date. Yeah, you could use a library, you could um, this is fine. This is fine. We're using constants all along the way to define the date, the month, the year, the hours, the minutes, the seconds, right? And then we're just turning that out. So this to me is fine. And we're recognizing that we need a higher level abstraction for the data that we're working with, right? In this function. So that's great. I like that. Yeah, it could be, you could do some things to kind of shorten it further, but this is great to me in comparison to some of the other things that we've seen, right? So let me close this out. Let me check on that time. How are we doing on time? 38 minutes. I think we're good here. There's definitely some, like I said, there's definitely some room for opportunities here to introduce more functional programming. They're trying to be functional in certain areas, right? This is an attempt to be functional and just efficient, right? By not, like I said, not repeating yourself and just typing the same thing out. The sort and the map and the filter that we looked at earlier, that's an attempt to be functional. But then we've got these try-catches everywhere. I think we could clean that up by just introducing a try-catch function. And then by introducing a try-catch function, we introduce functions for our try and then functions for our catch, which we've seen already that several times there's really no logic for the catch, which is fine. But it cleans up the code. And when you can give your functions meaningful names, the code reads better, in my opinion, and in practice, right? There's cascading ifs again into a try-catch, right? get it the last n lines of a log text. Limit. Oh yeah, we can definitely do this better. We can definitely do this better. We can definitely do this better. This is another good candidate. Get recent logs. Yeah, this is another great candidate for functional, to make this more functional. Calculate the cost for usage entry. Oh yeah, no. Okay. Okay. Yeah. So again, very normal JavaScript code. We have a let. We are mutating this guy by just adding, right? Adding, and then returning the cost. This is a reduce. This is a reduce, right? You're summing. So, yeah, and then you, based on some conditionals, as long as you got more than 0, you're gonna go ahead and add these tokens, basically. Yeah, this should be a reduce. I don't know why this isn't a reduce, but okay. So calculate cost is a great. So usageDB is a good file for opportunities to improve this in a functional way. Okay. Fetch API keys, or try catch again. Create a map from API key to key info. Reduce. And get usage stats. Wait a second. What's going on here? 20 most recent requests. Didn't we just look at this somewhere? Where was that at? Are we copying and pasting code? It looks like it. It looks like it to me. Again, this is something that you just find, right? In open source projects. It's I get it. People are trying to move fast, they're trying to move quickly. And get recent logs. Okay, so that, where was that? Append, format. Save. Get usage database right here. So in this function, get active requests. So get active requests, not calculate cost, get usage status. So get active request and get usage status has the same code. And again, it can just be a function, right? This is getting the most recent request. We can just make this a single function that both those get usage stats and this big one here, sorry. I lost. Get active request and it's get active request. Yeah. So get active request and get usage status. Usage stats, excuse me. These both can use the same function to get the most recent request in history, right? Okay, so I think I've seen enough here. I'm going to go ahead and just stop it right here. And I think next time we'll start diving into some of this and start refactoring it. So I will see you in the next one.